For Module 3, so practice problem in production planning and control. So for question number 1, so the total processing cost for running shoes is 18 pesos. So the Eagle Shoe Company start production of 620 pairs of shoes weekly. And the average weekly yield is 92% with 8% defective shoes. So 1/4 of the defective shoes can be reworked at a cost of 3.75 pesos. So compute the quality productivity ratio or the QPR. So letter A 7.2, B 6.1, C 5.2, and D is 4.2. So for this problem, so ang formula natin for QPR is equal to good quality unit over input times processing cost plus defective unit times rework cost times 100%. So kita naman natin dun sa ating sample problem, ang input natin is 620 pairs of shoes. Then meron tayong percentage of good na 92% na kung saan yung percentage ng defective is 8%. Then processing cost is 18 pesos. Then rework cost is 3.75 pesos. Wherein dun sa ating 8% na percentage ng defective, 1/4 lang yung pwedeng i-rework. So meaning 1/4 is equal to 0.25. So i-substitute lang natin yung mga given dun sa ating formula, 620 times 0.92 plus 620 times 0.08 since 1.92 is 0.08 times 0.25 over 620 times 18 pesos plus 620 times 0.08 times 0.25 since 1/4 times 3.75 pesos times 100% is equal to QPR na 5.2%. So ibig sabihin for this problem, ang sagot natin is letter C. So for question number 2, so same problem pa din. So related to dun sa question number 1. Pero ang gagawin natin is to compute the QPR if the production rate is increased to 760 pairs of shoes per week. So tingnan natin, pag ba nag-increase yung input natin or yung production, magbabago ba yung QPR natin? So i-check natin. So yung choices natin, 7.2 for A, B 6.1, C 5.2, and D 4.2. So for the formula for QPR, same pa din, good quality units over input times processing cost plus defective unit times rework cost times 100%. So same pa din yung ating given, ang nabago lang is input na 760 pairs of shoes. So substitute lang sa formula. So 760 times 0.92 plus 760.08 times 0.25. So lalabas pa din na ang QPR natin is 5.2. So meaning kahit ang gawin mo ay 1,000 na input or production, then 5,000 na production, ang lalabas pa rin dyan ay QPR na 5.2%. So ibig sabihin kahit anong itaas natin or ibaba natin sa input, basta same pa din yung rework cost, same pa din yung percentage ng goods, same pa din yung processing cost. So walang magbabago sa QPR. Same pa din. So yun. So for question number 3, so related pa din sa question number 1, compute the QPR if the processing cost is reduced to 16.5 and the rework cost is 3.2. So bali 18 to 16.5 and 3.75 to 3.2. So choices 7.8, 4.2, 6.2, and 5.7. So ang gagawin lang natin, substitute lang ulit dun sa ating QPR, wherein yung ating input ay yung ating previous, yung 620 pairs of shoes, hindi yung ginamit natin doon sa question number 2. So 620 times 0.92 plus 620 times 0.08 times 0.25, pero yung ating processing cost is 16.5. Ito. Then ang ating rework cost is 3.20. So ibig sabihin, ang lalabas dyan na QPR is 5.7%. So tumaas yung ating QPR since nagbago tayo ng processing cost at saka baba din ng rework ko. So for question number 4, so paano naman kapag yung percentage ng good quality unit yung nag-increase, so from 92% to 96%. So yun yung ating question number 4. Mag-i-increase ba yung ating QPR? So i-check natin. So yung solution, so same pa din yung ating gagamitin na formula. So QPR, then yung existing natin na input, yun pa din 620, pero yung percentage ng good is 96%. So So, dati 92, ginawa nating 96. So, kung 96, ibig sabihin yung percentage ng defective natin is 0.04, hindi siya 0.08. So, bali, para makuha yun, 1 minus 0.96 or 0.96. So, 4% or 0.04. Then, yung ating processing cost, yung existing pa rin sa question number 1, 18 pesos and 3.75. So, substitute dun sa ating formula. Then, makukuha natin na QPR is 5.4%. So, sagot natin is letter A. Then, for question number 5, the Falcon House Furniture Company manufactured 2-drawer mahogany file cabinet that are sold and assembled through catalog. So, the company initiate production of 120 cabinets packages each week. Then, the percentage of good quality cabinet average 81% per week. And the percentage of poor quality cabinet that can be reworked is 50%. So, determine the weekly product yield of file cabinet. So, pag sinabi natin weekly product yield, ito yung good quality unit. So, ilan ba yung pwede nating, for example, mabenta sa given na meron tayong percentage ng poor quality cabinet. So, choices natin, 107, 105, 109, and 111. So, yung formula natin, so yan, yield is equal to input times the percentage of good quality plus input times 1 minus the percentage of good quality unit times the percentage of rework. So, ang input natin is 120 cabinet, then meron tayong 81% na percentage ng good at 50% na rework. So, substitute lang, 120 times 0.81 plus 120 times 1 minus 0.81 times 0.5 is equal to 108.6 or 109 cabinets. So, answer natin is letter C. Then, for question number 6, if the company desire a product yield of 115 units per week, so what increase in the percentage of good quality product must result? So, pag nag-increase yung ating product yield, so di ba nakuha natin kanina is 109, ano yung ating percentage ng good quality para yung yield natin is 115. So, yung choices natin, so 90%, 92%, 95%, and 97%. So, yung gagawin lang natin, so since meron tayong yield na kailangang i-obtain na 115, so 115 is equal to 120 yung ating input, then kukunin natin yung value ng x wherein x is the percentage of good quality. So, equate lang or substitute lang. Then, lalabas dyan ang value ng x is 91.67 or 92%. So, meaning para ma-achieve natin yung 115 units na yield or good quality units, so dapat meron tayong 92% na percentage ng good quality. Then, next, question number 7. So, the number of weekly customer complaints are monitored at a large hotel using a C chart. So, complaints have been recorded over the past 20 weeks. Then, calculate for the upper control limit and lower control limit using the following data with 3 sigma control limit. So, may given tayo na week 1 to 20, then yung number of complaint natin. So, using C chart, so kunin natin. So, ang formula natin ng sa C chart, C bar is equal to the total number of defects over the number of sample. Then, ito yung formula natin ng pagkuha ng upper control limit and lower control limit. So, kukunin lang natin yung summation ng total number of complaint. So, ang total natin is 44, then meron tayong week 1 to 20, kaya ang total number of sample natin is 20. Then, may given tayo na 3 sigma limit, kaya Z natin is 3. Kunin muna natin si C bar. C bar is equal to 44 over 20 is equal to 2.2. So, 2.2 na C bar plus 3 na sigma multiply sa square root ng 2.2. So, ibig sabihin yung ating upper control limit is 6.65 and lower control limit is negative 2.25. Pero wala tayong negative na limit. Kaya ibig sabihin, ang ating lower control limit is equal to 0. So, ibig sabihin ang range natin is 0 to 6.65. Answer natin is letter C. The next, for question number 8, so a production manager at the manufacturing plant has inspected the number of defective tires in 20 random sample with 20 observation each. So, following are the number of defective tires found in each sample. So, the P control chart is to be made for this data. Then the proportion of the control chart is, so ano daw yung ating p-bar? So yung choices natin, 0.05, 0.10, 0.15, and 0.20. So ano ba yung ating formula para makuha natin yung p-bar? So may given tayo na sample na 1 to 20, then meron tayong number of defective tires per sample, and meron tayong number of observation per sample. So ganito yung mga problem ng p-chart. Merong sample and also the observation. Parang each sample merong number of observation. So yung p-bar natin, total defective over total sample observation. So pag sinabi natin total sample observation, i-multiply natin yung number ng sample sa number of. So ilan ba ang number of sample natin? Meron tayong 1 to 20 weeks. Then meron tayong 20 observation per sample. Then total defective tire, kukunin lang natin yung sum nito. Ang sum nito ay 40. So 40 over 20 times 20. So ang p-bar natin is 0.1 or 0.10. So letter B. So proceed tayo sa question number 9. So referring to the table, which expression best describe this chart? So letter A, at least 1 point is outside of the control limit. B, increasing trend is detected. C, decreasing trend is detected. Then D, the process is in control. So para ma-check natin, kailangan muna natin i-determine yung range or the upper and lower control limit. So para makuha natin yung UCL and LCL for P chart. So ito yung ating formula, P bar plus Z sigma P, then P bar minus Z sigma P. So kapag wala tayong given na Z, ang gamitin nyo na lang ay 3. Kasi ito naman lagi yung ginagamit, 3 sigma limit. So P bar natin is 0.1, Z is 3. Then, kunin natin yung kanyang UCL. UCL natin, 0.1, since yung P bar, plus 3 multiply sa, so ito yung formula for sigma P. Square root ng P bar times 1 minus P bar over the number of sample, or 0.1 times 1 minus 0.1 over 20. So makukuha yung UCL is 0.3012 and yung LCL is negative 0.1012. So sabi ko nga wala tayong negative na LCL kaya 0 ang ating lower control limit. So 0 to 0.3012. So i-check mo lang dito kung meron bang lumabas sa ating control limit. So para ma-check kung may lumabas dun sa ating control limit, so itong number of defective tire per sample, i-divide natin sa 20 observation kasi meron siyang 20 observation. So 3 divide 20. So ano ba yung 3 divide 20? Ang 3 divide 20 ay equal sa 0.15. So pwede namang hindi mo i-divide lahat. Kunin mo lang alin ba ang pinakamadaming defective tires. Ang pinakamadaming defective tires ay yung sa sample number 17. Sa sample number 17 ay may 4. So, divide natin yung 4 sa 20. So, ibig sabihin 0.2. So, yung 0.2 ay pasok pa sa 0 to 0.3012. Kaya, ang sagot natin dyan is the process is in control. So, yung answer natin for this problem is letter D, the process is in control. Then, proceed tayo sa question number 10. Now, a production manager at Ultra Clean Dishwashing Company is monitoring the quality of the company's production process. There has been concern relative to the quality of the operation to accurately fill the 16 ounces of dishwashing liquid. The product is designed for a fill level of 16.00 plus minus 0.3. Then the company collected the following sample data on the production process. So referring to the table, suppose the analyst construct an R chart to see if the variability in production times in control is. So what is the upper control limit for this chart? So choices natin 0.82, 0.83, 0.86 and 1.02. So meron tayong 10 sample. Then each sample meron tayong 4 observation. So ang unang gagawin natin is to determine the range in each sample. Para makuha natin yung range, ang formula natin is the highest value minus the lowest value. So each sample, kukunin natin yung range niya. Ito yung sagot dyan. Nakalagay naman. Then, after makuha yung range, kukunin ngayon yung summation. So, summation ng range natin is 4.48. Then, i-divide natin sa 10 sample. Ibig sabihin, ang R-bar natin is 0.448. So, ano ba ang formula ng UCL natin? D4 times R-bar. So, check natin sa table. Ano ba ang value ng D4? Since meron tayong 4 na observation, 2.28 yung ating D4. 2.28 times 0.448 na R-bar. So, 1.02 yung ating UCL. So, for question number 11, referring to the table, suppose the analyst construct an R chart to see if the variability in production times in control. Ano naman daw yung lower control limit for this R chart? So, ang formula natin ng lower control limit ay D3 times R-bar. So, alam na natin kanina yung R-bar. Meron tayong 0.448. So, para makuha yung D3, check natin. Meron tayong, etong nakalagay dito, ito ay, baka malito kayo, ito ay para sa number of observation. Hindi siya sa mismong number of sample. So, dito sa ating problem, meron tayong 4 na observation. 4, ang katapat ng D3 na 4 is 0. So, 0 times R-bar na 0.448 is equal to 0. Kaya ang ating lower control limit for this problem is letter A, 0. Then question number 12, suppose that the analyst construct an X-bar chart to see if the production process is controlled. What is the lower control limit and the upper control limit for this chart? So kanina, ang ginamit natin is R-bar or R-bar. So kapag X-bar, kailangan muna natin kunin yung R-bar kasi yun yung nasa formula. Or gagamitin natin si R-bar para makuha yung X-bar natin. Or yung LCL and upper control limit ng X-bar. So, ito yung ating formula. For upper control limit, X double bar plus A2 times. Ito nga yung sinasabi ko, R-bar. Then, LCL is X double bar minus A2 times X-bar. So, ang gagawin mo naman, kung kanina ang kinuha mo ay range, ang gagawin mo naman ay yung kanyang average or the X-bar or mean. So, mean ng each sample, ito yon, nakuha ko na yung mean ng each sample. Then, kukunin mo naman yung sum ng X-bar. Ang sum niya ay 160.135 over 10 na sample. So, ibig sabihin ng ating X double bar is 16.0135. Then, para makuha yung ating UCL and LCL, so, check lang natin yung value ng A2. Ang value ng A2 na 4, katapat is 0.73. So, substitute lang. Ang lalabas na UCL is 16.34 and LCL is 15.69. So, answer natin is letter B, 15.69 and 16.34. Then, for question number 13, so which expression best describe this chart? So, dun sa ating kanina, di ba nakuha na natin yung control limit. So, siya ba ay increasing trend, decreasing trend, at least one point is outside or in control? So, yun. So, yung i-compare lang or yung value ng X-bar na nakuha natin in each sample, i-check natin kung pasok ba dun sa ating upper and lower control limit. So, 15.69 to 16.34. So, 16.0475 pasok, 16.02 pasok, 15.9675, so pasok pa din, 16.0725, 16.2125, 15.5975. So, nasa baba siya ng 15.69. So, 16.15, 15.89, 16.1, and 16.07. So, ibig sabihin ng ating answer, at least 1 point is outside of the control limit. So, letter C. Then, for question number 14, 3 bagging machine at the Crunchy Potato Chip Company are being evaluated for their capability. So, the following data are recorded. So, meron tayong machine ABC and standard deviation 0.2, 0.3, and 0.05. If the specification are set between 12.35 and 12.65 ounces, determine which of the machine can produce within specification. So, ang formula natin gagamitin is the process capability or the specification width over the process width, or the upper spec minus the lower spec over the 6 sigma. So, ang upper spec natin, 12.65, lower spec is 12.35. Then, meron tayong standard deviation for each machine. So, process capability for machine A, so substitute lang, 12.65 minus 12.35 over 6 times 0.2, so 0.25. Then, process capability for machine B, so using standard deviation of 0.3 is 0.17, and process capability for machine C, at ay machine C, so 0.05 na standard deviation is equal to 1. So, meaning, yung magiging value na 1, yun yung mas capable na makapag-produce ng good quality unit. So, ibig sabihin for this problem, ang answer natin is letter C, machine C. The next question number 15, processes mean of 9.2 gram and a standard deviation of 0.2 gram. So, the lower specification limit is 7.5 gram and the upper specification limit is 10.5 grams. Compute the CPK. So, choices natin 1.89, 1.44, 1.98, and 1.66. So, yung formula natin ng CPK, upper spec minus the process mean over 3 sigma, and process mean minus lower spec over 3 sigma. So, parehas ng formulang yan ay gagamitin. Then, pipiliin lang natin kung alin yung pinakamababang CPK, then yun yung ating answer. So, yung sa given natin, meron tayong upper spec na 10.5 and lower spec na 7.5. Then, process mean 9.2 and standard deviation of 0.30. So, substitute lang dun sa formula, 10.5 minus 9.2 over 3 times 0.3 is equal to 1.44. Then, yung another, yung process mean na 9.2 minus 7.5 over 3 times 0.3 is equal to 1.89. So, mas mababa yung 1.44. So, ibig sabihin yun yung ating CPK. So, for this problem, letter B yung ating answer.